Hello, hello. It's last day of January 2023. It's a SIG Node Sidecar Containers Working Group meeting. We have some agenda items today. Let's get right into it. So first agenda item I added it. So I made a presentation of Sidecar cap to a security team here internally in Google, and they suggested, generally they received it very well. One thing they said that may be helpful, even though it's not like it's likely will only be useful in a very big organization, is to have ability to specify like some no exact policy on init containers. So if we can create like some ACL for init containers specifically and be able to just like have a blanket policy on that, it will be very useful. And I'm not sure, like I didn't dig deeper into that, like how do like is it already possible or we need to do something about it? But this was one of the idea, like how we can have more privileged sidecars containers, which defined as a need. And cluster administrators today, they need to pick specific individual containers to disable no exec, but with sidecars, you probably can just do blanket for all the init containers, which may help in certain scenarios. Does anybody know more about like how this policy work, and is it possible today?
Possible to express it or possible to add it?
Yeah, possible to express it today. Like, is there any work needed, or it's something that we need to fix?
Nothing discriminates between the two container types today in any of the policies that I'm aware of. So, so anything in tree, nothing discriminates on which type of container it is. So it would at least have to have something like that.
Okay, so we need to add something to this to enable this. Okay,
you need to at least make a case that no exec is useful in that context. There's enough of the flags already there. I think it'd probably be good to at least get, there needs to be like a pretty good capsule definition, but it'd be a good topic. I don't think anybody would really have an issue for init containers and regular containers. Probably also this would apply to ephemeral containers as well, because the classes of use case for ephemeral containers might lead you towards needing to do some of that. Init containers you'd be trying to avoid. Classic Linux trying to drop privileges, and the regular containers would be denied that.
Okay. Yeah, I probably put it as a beta targets, beta goals. So we're not dealing with alpha because I think it's like whatever decision we will make, it's an additive task. It's not a requirement. Okay. Next thing I wanted to discuss is I think cap approval going pretty well. We don't have any large concerns any longer. The only question left is what do we use for to indicate that sidecar container already started. So there are, I have a commit like special commit for that. So we can rely on the readiness probe. We can wait for container to get into ready state and then decide that it's ready, like, and start new next init container. We can wait for startup probes to complete, and then once startup probes completed, we decide that container is started, and we call initialization of next init container. And lastly, we can do the same as we do for regular containers. We can just wait for post start hook to complete. It's synchronous. I'm sorry. And once it's completed, we can proceed with initialization of next containers. So post start is very easy to implement. It's one synchronous call, and basically when you initiate container, just wait longer for post start, and you will be done with that. The problem with this approach is people will likely need to implement more in their post start hook, so they likely will have some common logic that very similar to startup probes, waiting for some maybe some correlating of some endpoint, waiting for endpoint to start up. And also, post-start hook is very hard to troubleshoot today. Apparently, like we don't change the status of container. We just like a container just hanging in this like limbo, like something is happening, and we have no visibility in what's happening. That may be fixed, but this is the current state.
I would say that's just an argument that is not an argument to do it a different way. That is a gap that would have to be addressed potentially for early consumers.
Yeah, I agree. You're breaking up, Clayton. Clayton, you were breaking up, at least for me. I got
same here.
I'm just,
yeah. I think I heard is okay. So yeah, I agree that I mean, it's not an argument against, it's just argument to fix it and make it better. Next thing, startup probes. Startup probes harder to implement, and I think what makes it harder is we need to have some state of containers that is started, but readiness are not initialized yet. I mean, there is no state like that today. Like today, like startup probes ended and readiness kicks on, and readiness will mark containers ready. So it will be extra work, and the difference between startup probes and post-start hook is in very small and trivial sidecar containers that doesn't want to wait for initialization of a container. Startup will become slower. So we have this jitter before we start probes, and then probes will kick in, and then state will change, and only after that, like next container will start initialization. So for very trivial case, we will slow down, but in general, I think for like a regular case, it will be very similar to post-start. And lastly, readiness probe, which we went with initially, it's quite limiting because we tie together readiness as I'm ready to serve traffic and I'm ready to be included with liveness. So like we eliminate scenario when startup like sidecar containers decide that it started and it's fine to proceed with the initialization, but it's not ready to serve with traffic. It wants more initialization to be done in parallel, and it doesn't want to delay anything else. It just wants more time for itself. So this scenario will be limiting this scenario, and yeah. So also it delays even further between startup and readiness probe. Like when startup completes, you need to wait for readiness to kick in, and then like readiness will need to succeed at least once. So it will be extra time spent on initialization.
Can y'all hear me?
Yeah.
Sorry. Yeah, just driving and it was bad signal. I was gonna say I do agree with the previous justification not to use readiness. Like there have been other places that have tried to conflate readiness with other constructs, and I don't think it maps. Like this is about we are changing init containers from running to completion to reaching a criteria threshold initialization to move on. And I think, I buy a lot of the arguments that have been made in the CAP and you brought up as well, Sergey, which were ultimately we're looking for what is the clearest indication of a gate. I would that if we have overlapping constructs, and so in that case right now, at least so far, we've talked about startup probes and post-start hooks. Both of those qualify as, because those features exist, because they gate startup, and because the construct that we're basically offering here with a sidecar is the ability to fail initialization if a series of startup criterias haven't been hit. I would argue that the presence of both of them have to be taken into account. We would need to come up with something reasonable. And the alternative, which I think was discussed in the CAP already, which was to not have any way to gate initialization And that's kind of frustrating. The post start hook by itself has a pretty clear argument that it has to be succeed to be considered started. And so really, I think I would break this down into, do we need anything within the container or not? And if the case that we have to have it is strong enough, we should, I think we have to support both mechanisms. And if the user chooses to use both of them, we need to have the clear rationalization for what their behavior is. If you specify a post start hook and a startup probe, I think we would have to take that into account as well. Do startup probes take post start hooks into account today?
Yeah, post start
no?
is first, and then startup will kick in. So it's not parallel.
So then I think because of that, I would probably argue, while there is a gap, as you noted, and indicating that the post start hook has succeeded, it's still like we have a linear sequence. Try to keep as few things as possible from behaving differently. And the presence of, if you've added to the spec a probe or a hook, you are indicating that you wish to gate startup, which sounds like, just from a consistency from the user expectation point, I'm buying the argument here that both of those are blockers to the move past the init container. Are there any arguments against that others have made?
I'm just arguing with myself that including probes into this initialization will delay start of container. But
you can choose not to use. You can choose not to use that probe, I think, is what the argument would be. And if you have no probes, then we just go right away. The moment that container is started, like either it starts in parallel or we just start it and move on. Because the implication of restart always would be if there's nothing gating you moving next, once we understand that we can start, like we get to the point of calling start container, we basically have to move past anyway, right? Or are you arguing something different?
No, it's fine. This eliminates this argument. Yeah, I remember now that another argument against startup probes was that regular containers doesn't behave the same way. So we change the behavior for init containers to delay for startup probes, to block on startup probes, and it's different. And different is always puts under question. I know how people.
I don't either. I'd have to go back and re-review it. It's been a while since I've looked at startup probes, but certainly if an end user would believe that they block startup and that we communicate that in other ways, I think my argument would always be try to integrate the other existing features in. We don't get to ignore existing features in a design. We have to integrate the whole, because otherwise it creates more. Unless it is, but I don't. Just based on what we've said here, if you specify a startup probe, I think a reasonable user would expect you haven't started yet, and so they would expect that.
You're breaking up again. So let's. Okay, so feedback here is startup probes generally good thing. Maybe we need to. We likely need to account for both startup probes and post start hook. Is there any other opinions on the call today? No. Okay. Let me move past it. So yeah, with this two, I think I don't see any other concerns on the cap. So cap seems to be not have any other unresolved questions. I think we can write down what we want on the startup hook and remove unresolved here. And once we do that, should be fine.
Hey, Sergey. Sergey, this is Vinay. I took sorry, I've not been part of this group for a little while, or this is the first time I'm coming in, so I might have missed a lot of context, but I added a couple of comments to the KEP, and in particular about the resize, having the resources allocated reflected in the pod. I am not in favor of doing that. It seems to be there is another effort that's going on to bring pod level resources as well. So it's going to conflict with that. And I don't really see what benefit we get from how do we justify that being in the API when you can compute that with a helper. And the second thing is when a pod is not scheduled, for the reason of resources not being available, it's already reflected in the pod conditions, if I remember correctly. Out of CPU or out of memory conditions show up there. So the information is already present. So I'm struggling to see why this is needed. And even if we were to add it, it's probably going to collide with the future potential use case for having resources for the pod level itself. There is one, the pod overhead, that's a different thing, but there's what we're talking about here is pod level resources. I believe you pointed me to a cap. Another cap of some kind.
Okay, to give more context for everybody on the call, as part of a cap, we wanted to, we changed the formula, how we calculate resources needed for pod, and feedback was that we need to expose it somehow, be it a metric, be it like some way. And I think another feedback was that pod status seems to be a good fit for this field. Vinay, I'm sorry, I didn't see your comments. Maybe I
posted it this morning,
Oh,
just like a couple of hours ago.
Okay, sorry. Yeah, and you're saying that you're not in favor of adding it in pod status?
Yes, I don't readily see why we need that when we can provide an API to compute that.
We already actually have a beta level metric that represents this. And that uses the same helpers. That was part of the reason to add those metrics for future change. I will say that's a really, really good point that I had not considered and actually needs to be completely discussed in the KEP. We are changing the observed resource model through the addition of a new feature. And there are migration implications. People forget to implement it. What are the impacts, et cetera?
I'm not sure I follow part of forget to implement it. There's a pod status and we will implement it, right? So it will be implemented. Like there are like proposal to change it in two places, like one in scheduler while pod is still pending, and then kubelet will update it whenever it has a change, right? Or whenever it's scheduled it.
Yeah. So another thought, I think this probably has already been discussed. The idea of introducing another container class like sidecar containers. Just looking at the service mesh example, it looks like, or one thing that's common to all these is that you want to have an init container that doesn't terminate, that continues to run. And to accomplish that, and you may want to start this before the init containers happen, which essentially brings the question of, okay, there are some containers which have an ordering requirement where you want to start this, and then you want to keep it running. But if you have the restart policy that's always, instead of having it just always, why don't you have always and never, and then have a container successfully exit? It will accomplish the same tasks. And then you are giving the sidecar container class the full treatment of the resources. So it's going to be accounted for in the same way as regular containers are accounted for, with a superseding restart policy. So if you have pod level resource policy never, and then you want the sidecar container to always be restarted and continue to run, then you specify a container level resource policy, a nullable value. And if it's there, then that's going to supersede what the pod level is.
Yeah, that's the idea. And the next step for us was that the formula that we will end up is quite complex. So we need to like iterate through init containers and calculate all the maximums, like sliding window of maximums, and then sum up all the regular containers and then add pod overhead. So it's quite involved computation. And to
Well, I would.
Yeah.
I would actually argue, and again, I agree that it is more complicated. We're effectively making an argument that this kind of container, there's two classes of container. There are the ones that they run with the lifetime of the pod, and then there's ones that run with the lifetime of run to completion before the lifetime of the pod. And every container that can run for the lifetime of the pod adds to the pod's total resources. And then every pod that doesn't runs to the peak. And I think that's kind of like, we need to formalize that. And that is the strongest argument that I've heard so far for a different struct, right? For introducing like a new type of, other container that is an additive construct that we add into the other calculations. Because my previous point, which I got caught off on, I'm sorry, was it's just anytime we add a new behavior, the obviousness of the change that clients have to take into account. So in this case, custom schedulers, the core scheduler, anyone who's written custom logic out there to calculate resources, that's a more complicated process when it's integrated into existing types than when it's a net new field or something. So I don't think the argument is we can't do it in init containers, but this is one of the best arguments I've heard for at least considering the total implication of resources and what's easy for people to react to. Because that's also another factor, is it's not just what's easy for the end user, it's also what's easy for existing consumers of those APIs to react to.
Okay, I bought that everybody need to change things. I'm just trying to understand how is it affecting the fact that we expose this as a calculated value, or we don't expose it as calculated value.
So we expose a metric today that exposes the calculated value already. That's a part of the metrics that the scheduler exposes. That's intended for consumers who are more capacity planning. Schedulers themselves will have to react to and add this feature. That's something that they would have to do normally. That's an understood part of it. I think the argument that we need to expose the calculated value on the API, I personally in having this metrics, driving that metrics for precisely this reason. It's hard for end users to calculate. And we made an argument there. We would not put it in the API at the time. Like we would not put calculated metrics values in the API. We always reassess that. I don't think we have to now for this particular use case.
I'm sorry, Clayton,
you need to address
you're breaking up quite a bit. Could you please repeat that, Clayton? We couldn't hear everything. At least I missed. I don't know. Maybe the problem is on my end. Did everybody get that?
No, breaking up.
Oh, okay.
Yeah, I followed all the way to the statement that we didn't expose it before and we don't want to expose it specifically for this feature, but I didn't get a reasoning.
Right. Yeah, my reasoning is a little different from that. I see that there is a potential for conflict with another pod level specification of requests and limits. Besides that, the defined value of resources allocated, at least using that same terminology, its currently defined value is very different from what's being proposed here. The main argument against it for me is that this is set as the amount of resources allocated to each container at the container level by the kubelet when it admits the pod. So pod is admitted in an all or nothing deal. So all containers, if their requests are met, then it's going to get admitted. If not, it's going to be rejected. The pod gatekeeps that. The kubelet gatekeep that, does the gatekeeping for that. Now, introducing this at the pod level as a summation seems redundant, and if we can get that from the API, the consumers of this is users. We can have an API and have that via kubectl describe pod, and programmatically, if the API is available, like a metrics consumer or something can call that and get the information. And
I would.
if the yeah,
I
if the
was
only
gonna say,
reason
like,
to sorry, go ahead.
I was gonna say, like, stepping back, like, we have previously multiple times made the argument that the calculated values should not show up in the API. So I don't know that the bar is that high to say we shouldn't do it. We do have a API in the form of a metrics endpoint that provides it. I wasn't clear whether you were arguing for a third type of API or whether you were justifying that, more justification that we shouldn't add it to pod status.
Two things. Yeah, one is we should not add it to pod status. And I was also arguing for a third container type. So you already have, or fourth in this case, we already have init, we have the normal containers, we have ephemeral containers, add a sidecar container type. The overall, just reading this, I don't know the historic discussions behind this or if this was an intentional choice, but reading the KEP, I went through it yesterday. I've been a bit sick, so I really haven't grasped everything with a clear mind, but going through it, it felt like we are introducing the restart policy to differentiate, kind of allude to this sidecar container's existence by overloading adding restart policy and kind of overloading the meaning. I just feel why not be direct and explicit and just say, yes, this is an industry evolved and accepted thing, that concept is there. Let's bring it in and follow the common rules, and then sorry, I might be off my reservation here.
Well, and I think the argument for reusing init containers was ordering does matter in some use cases. And so there's an argument for integrating this into a container, clearly indicate ordering. And then there is an argument to separate it, to clearly indicate that this is a different, distinct type of container. And in that model, ordering is more complicated, but there are some other things that are clear. So we're basically talking about that trade-off, and it would probably be use case driven. If we have a strong set of ordering use cases that we can argue for, that might have more weight than this. And I think the resource argument is an example of the intuition of how a user and a system consumer approaches the intermixed init containers, increases the amount of confusion that all integrators will have leveraging this feature.
Correct. That's primarily, that seems to be the reason why I would want the sidecar container a separate class. And at least on the initialization, when you start it up, you go with the order in which it's specified in the YAML, and then have restart policy, not with just always, have always and never. So that gives the flexibility for, let's say you have sidecar container 1, sidecar container 2, and sidecar container 2 wants to use the connection that was established, some kind of service mesh connection that was established by SC1 to get some information and exit. That could be done in the application container, unless you have security privileges, that it needs extra security privileges. That could be the reason, but it can exit successfully, and that's perfectly legitimate thing to do, isn't it? It's not exactly
renaming init container section into like infrastructure container section or whatever, a sidecar container section. So it will achieve exactly what you're saying. So it will intermix init containers and sidecar containers. And it already exists. Like it just called init containers for some historical reasons mostly. So I think we went through this argument, and we end up implementing the same thing as we implement today already. But I want to return to this resource calculation. And I'm not super attached to expose it as pod status. I just think it's a very natural way to expose things, mostly because like we have two caps. Like this cap will change the way how we calculate, and then another cap that Vinay is working on is dynamic resources. We now need to know that pod request is between what is requested and what is about to be applied. So you need to pick maximum out of it, out of these two values. So formula will be more and more complicated. And metric wouldn't know about the status of kubelet. Metric doesn't know whether we already applied new request or we about to apply this new request. So for individual pod, you wouldn't be able to get this precise information from metric itself. You would only be able to get it from pod.
Yeah, you would effectively know after the kubelet has made the update, and then there's a period where it's been requested but not applied. And to be fair, the scheduler, like all schedulers, need to know the effective calculation. The kubelet also needs to have a similar calculation. There is an argument that why is the kubelet doing a calculation that it doesn't need to if other consumers have to do that exact same calculation. So that's certainly a good argument for status in a larger context.
Yeah.
Has there been any discussion about that with that? Like, is there a working group that has talked about these things all together?
No, not that I know of. And that's why Vinay came here. And I really appreciate, Vinay, you reading through and giving feedback. So I'm trying to understand how we can resolve it. Like one way to resolve it is to put it for beta requirement and say like in beta, we'll decide whether we want to expose it. It may work. I think, I don't know how many people will try to implement it right away and like they will really need this, but you always can give them like helper methods.
Well, honestly, I would probably say, I think even based on this discussion, like going into beta for me is going to be consumers of this have demonstrated a number of patterns and have given feedback on which patterns are frustrating. So like some of the arguments here are like the ordering. It's not clear to me that we have a really broad canvas of ordering, examples and use cases called out yet, because we're still kind of working through it. We can imagine a really good analysis of people trying to use this and saying, we'd be okay with, a init container and then a regular container, or people saying, no, we have to have some of these more complicated constructs. And then there's people who've done 10, 15 init containers. They're kind of the outliers, but I have seen decomposed logic and I've seen, all-in-one logic. I'd be much more comfortable with a good chunk of alpha consumption, regardless of what the structure is, that we then look at the input process for beta as the API shape should match the use cases. And if we need the clarity or if we need the status API for metrics, both of those feel like good criteria for beta.
So one of the sort of the uses for the status API was just I've seen users that struggle currently with trying to figure out how many resources a pod needs to schedule. If you have a pod that's pending, they have to. Not all of them know that, well, you need to go look at your init containers and take the max. And I think we sort of get by with the fact that for the most part, workload pods end up having larger resource requests than a init container. So for the most part, it doesn't matter. But I can see if kubectl describe pod does show that value, then that also solves a problem for the end user, because they can just describe a pod and get the value. I guess what would be frustrating to a user is a pod doesn't schedule. The condition just says I don't have enough CPU on a node. Now I need to go look at this multi-step formula and manually look at the pod spec and calculate these values to figure out exactly what size node I need to replace this node with to actually get my pods to schedule. But yeah, if kubectl describe pod shows it, and you have some sort of helper methods within the Kubernetes code that other schedulers can use, then that seems to also solve the problem without exposing it as a status.
We could also expose a virtual resource sub resource on a pod that would convey some of that information. So I think this is also a good example of and I appreciate it, Todd, the use cases it would help to look at holistically, some of those 3 or 4 different types of use case. I'm a system administrator wanting to do capacity planning. That was actually what the original metrics were intended for. So ask the scheduler, same model, same code. Sergey brought up the one of you have a multi-stage process whereby you set an intent and then the kubelet realizes it and reacts and needs to convey that correctly. And then you also kind of have the impossibility aspects of I'm trying to schedule something and it is a dynamic system and some of the information is pretty far downstream. Having a place to coordinate and report what resources are needed is actually very useful as well. And then that gets into, do you need to do it in bulk, which is kind of the capacity planning use case? Is it more diagnosis? And then is it a part of a fundamental centralizing the calculation so that fewer components of the system? Because I think like another point as we're bringing this up is the definition of the resource model is defined by the API. Generally in Cube, we might have extensions that have opaque resource models outside of the core pod model, but the expectation would be the definition of the pod model is what defines the resource model, the KEPs that are approved, the feature gates that are on, and the expectation that all of the kubelets and all of the schedulers on the system respect those values is kind of the default assumption we have that most users work within. Is it unreasonable of us not to try to summarize that versus pushing it into all the different places in the code, right? If we make an API change that says this field should exist, we're effectively saying, if you're looking at this API object, you should assume that this works this way. Why are we making everybody have to go recalculate it themselves? Describe include.
So Clint, I see you saying that there may be like this may be a way to implement it. There may be other ways to expose the same information beyond pod status. What do you have any recommendation how to resolve it? Like, so you're saying beta is not an answer, right? So you want some answer in the alpha.
No, sorry. I was actually trying to say my bias, I think in all of this, like whenever, one of the lessons learned for me from init containers was we gathered a bunch of use cases, but the evolution of init containers in the kubelet took a long time. And it took users and usage patterns to understand the scope of what people needed out of init containers. Because we're coming in with sidecars, we have a pretty broad set of desired behaviors. My argument was, I think we should look at getting the core mechanism in alpha, and it would be okay if a criteria for beta was assessed how much information we need about the resource model to decide whether to enter beta. Do we need the status API? If so, that should be a prerequisite for entering beta as we've gone through that process. The same thing for the ordering problem. How much ordering complexity do we need? And are sidecars used often enough and likely to be an often enough portion of all init containers that separating them out is going to be better for end users in the end. So I think some of this is, I'm almost arguing we need to be getting experience with hands-on usage of the init container patterns as a prerequisite for entering beta anyway. Can we use that to potentially do a little bit more work? Can we use that to defer some of these questions or put them down explicitly in the KEP as we want to answer this question with actual hands-on feedback from use cases?
Okay. Vinay, do you have any large concerns with this pod status? Do you see how else we can resolve the scenarios that Todd listed? Like how customers know exactly what's going on?
I think kubectl describe can do it. In fact, I remember probably in the previous iteration of this implementation did some changes to the describe API to show the requested, which is the desired resources, and the allocated, which is the what's actually there for the pod at this time as it is running, and then the status resources. Made those extensions. So if that information, if all we need is to get that information out via the API for describe, I think we can do that. Having it in the pod status, for me, I think we need a really high bar to justify that. Like how does it programmatically, how does it equip the user to take, how is it actionable? What can the user do with that information? That's kind of unclear. So any details on that might help resolve, okay, yeah, we really need this. Because I can see the sidecar container. Yeah, I'm seeing both sides of the argument now, but having a new class that felt like the instinctive, yeah, this pattern has been there and people are trying to do all these tweaks. There are projects out there which, have you do the birth and death and then order it in some way. Give an order and give the restart policy so that in that order you can have some containers come and run forever, the sidecar containers. And if some container needs to start and then do some work after the sidecar communication, like the service mesh proxy envoy or whatever is started, it needs to do some extra work to get some at higher privileges and then exit, let it do that. I have to go through all the use cases, problem statements once again to be sure, but this seemed to be a fitting way of like having the restart policy at per container level. Yeah, I'm a go for that. To summarize, and the resources allocated at the pod level, at this point, I feel we shouldn't do it. We need stronger justification to have it, to have it in the pod status. Excuse me. I'm still recovering.
Aren't you all this season? Like people are either sick or recovering.
And no, this is something, I don't know what he got. It's not COVID, it's not RSV, it's not flu. I got all those tests done. It's some kind of it's been bad. Like last time I got this sick was 3 years ago. So yeah, that's quite a bit.
Okay. So I think the summary is we want to get more feedback, list scenarios a little bit more explicit. And in order to not block this cap, I would probably set as a goal for beta in alpha tentatively. Okay. I want also to get into specific implementation tasks that we can start already. And one of the tasks that I stumbled on right away, it is init container, desharing init container and type from container type. If you haven't seen this, what we discussed is that we want to add restart policy and we want to make a minimal API change. So we wanted to get a restart policy only to init container type and not to regular containers and not to ephemeral containers. Unfortunately, it's not possible with the typing system we have today because init container has the same type as a regular container, and the ephemeral container has like one more field than a regular container, but it has to has all the fields of regular container as well. So if we will add restart policy, it will automatically, like without any change of type system today, it will automatically be added to all types of container, including ephemeral. This is not ideal. So what we've been discussing is let's de-share init containers from regular containers by forking types. And I wrote this proposal how type forking can be done. Unfortunately, it's not like as straightforward as it turned out to be. There are some concerns, and mostly concerns are from external validators and external processors of container types. So there are third-party policies and libraries that using types as they declare today, and they assume that container is a common type across these three types of containers. So if we will split it into multiple types, that it can confuse all these validators. And there are like three, like Jordan pointed on three different types of validators, like ones that use type Go directly. Those, I think, easiest one to handle because we can have some helper methods for them and they will just reuse these helper methods. Then there is some other language or some like own implementation of the same type. So basically just getting like maybe they generating all the wrappers themselves and they just implement their own visit containers pattern in their different language. And lastly, there are some untyped validators, like some regex rules or whatever. They also assume some types. I think last one is easiest one, likely easiest one, because it's just look at YAML and apply YAML rules. And we wouldn't change any YAML definition for, at least for common fields. So this shouldn't be affected. But this first two, and as I said, first one is maybe not as affected because they need to change code. Like they will need to use new helper methods, but also maybe not that critical. The most critical one is second pattern when people generate some wrappers themselves and implement their visit pattern. And I'm not sure how many of those there are and how to resolve this problem. So like de-sharing type will definitely break a lot of consumers, but and we have a choice of not breaking them and confusing people by adding a field that is not being used by all containers. Alternative is to break those customers and have less confusion for end user. And this issue still haven't resolved. I mean, it's still open, and I don't know, like if we want to discuss it on this forum, or you want to just read it offline and comment there.
I definitely want to read more about it. It definitely sounds like a good idea, but at this point, is it going to be easy to do it? No, I doubt it.
It will be harder and harder with every new release. And one example I gave is there is a proposal, like it's not, this proposal may or may not go in 127, but whatever it will be, there is a proposal already that takes creates a new gRPC API, and this gRPC API assumes that all containers has the same type. So you just pass container object through this API, and since it's container object, you already stuck like I mean, de-sharing types on this gRPC API will be yet another task we will need to make when we decide to de-share these types, if we ever decide to do that.
So it's like bite the bullet kind of situation. Okay.
Yeah. Okay. Yeah, if you have a comments, please comment to this cap. And if you have experience with consuming these types, I thought you said that you wrote some schedulers before. How the schedulers? Is it Golang? Do you use types code directly?
Yeah, and so I work on Carpenter and wrote Carpenter's scheduler consolidation. So we use we use the Go based types for all of these. So yeah, it would affect us. It's probably it's a change, but there's also like every Kubernetes version, there's a change related to scheduling as well. So it's yeah.
There's not a big surprise, you say?
Yeah.
Right. Yeah, breaking existing customers is going to be like, I don't know if that's something we should do, and unless it's absolutely necessary.
And if you didn't recompile, you still can use existing types, right? So they will work. You can use client Go from previous version and it still works. It just doesn't understand new fields. We wouldn't break backward compatibility types wise, but we will break compatibility like Go type wise.
Yeah, and that happens anyway. You know, as something moves from like V1 beta to V1, and V1 beta 1 drops out or something. So as Kubernetes versions increase, you as a consumer, you basically with every release, there's some change we need to make to be able to support it.
Okay. Yeah, if you can comment on this issue, saying saying exactly that, that may be helpful, because I don't know, I don't know how to resolve it, how to weight properly components written against Kubernetes versus end user and type complexity. Okay, and I wanted to highlight Todd is working on what we discussed before. Yeah, resource calculation logic centralization. So I didn't find your PR very quickly, Todd. So if you want to highlight it, please share with me or send it in chat. Yeah, I thought that forking init containers and container type can be easy done before we start implementation. Apparently, it's not easy. Needs more thinking. Logic centralization is we have many places in code base with resource usage of pod, and Todd is working on combining them all together. And before this discussion, we thought that we will expose it as a pod status also before we even start cap work. But apparently we need more approvals for that. Okay. And yeah, this is under question now. Then I also put some implementation some end-to-end tests. We don't have all end-to-end tests for all init container behaviors, and we need to get going on like describing that and writing tests. So we have some pattern like this is how end-to-end tests will look like, and when we'll add init containers, it's just additive change rather than re-implementing and everything. So this is another task that we can pick up. And after today's discussion, I think what we need to do is start it state for container. So we've been discussing that it will split startup probes and readiness probes. Then we'll need to have a new status for containers. And Matthias, you know this logic very well. Is there any problems implementing the status for all containers right now and then just inherit it for init containers? Or you wouldn't suggest to implement it for regular containers?
For the moment, I wouldn't want to touch it. But
I mean, we will need to touch it. We'll have to touch it for sidecars.
yeah, I have no opinion for the moment. I need to check again this part of the code.
Okay. So, I mean, just thinking generally, like if you implement the status, we probably want to have the status for regular containers as well, because like before readiness probes kick in, you will already see that status changed, right? So it may be a good idea. Anyway, this is another task, and this is all I came up with in terms of tasks we can already start doing. If anybody interested to take any of those, or like help with them, please take it and like start going with it. And once we I think all other implementation detail, like all other tasks, we need to have a restart policy flag on a init container to implement logic for that. So it will be like big PR, similar to this Vinay is trying to do for in-place updates, which will be carried over for a long time. Okay, so if you want to take any implementation tasks, like maybe you can synchronize on Slack, or you just create a GitHub issue for that. With that, I want to give you a couple minutes before SIG Node meeting. Thank you everybody for attending. Nice chatting with you. Bye.
Thank you. Congrats.